So we are continuing in section 1.5, and we just talked about the slopes of parallel lines and the slopes of perpendicular lines. So parallel lines have this same slope, where perpendicular lines have what is called negative reciprocals of each other slopes. When you multiply the two lines' slopes together, you will end up with -1. So, and the shorthand for perpendicular looks like this. So perpendicular lines have slopes that when you multiply them together, they're equal to -1. So this doesn't say to write the equation of the line, but it says to find the slope of any line that's perpendicular to the line whose equation is this. Now this equation is not written in what slope-intercept form, and it's not written in point-slope form, but it is written in the general form. And so this line, we're going to call it line 1. We're going to find the slope of line 1, and we'll do that by putting it into this form here. Because if we can put it into this form here, then we can say, we can look at the coefficient on x and say that is the slope. So in order to put a line into slope-intercept form, you have to solve the line for y. So you want to solve the equation for y. So that means I want to isolate y by getting everything by itself on one side of the equal sign. So I'm going to start by adding 12. When I do something to one side of an equation, I have to do it to both to keep the equation balanced. So I have x plus 3y is equal to +12. Then I am going to now subtract x from both sides. And I will end up with 3y is equal to -x plus 12. Now you may ask me, well, why didn't you write 12 minus x? Well, I can write 12 minus x. It doesn't matter if I write -x plus 12 or 12 minus x. It's the same thing. But why I'm putting the x in front is because I'm trying to get it to look like this form, this y equals mx plus b. So now the next thing I would do is I would divide by 3. And that means I have to divide everything by 3. And so dividing everything by 3, that will leave me with y. The 3 divided by 3 will be 1y. And then I'll have -x over 3, or I can pull that out in front to say -1 over 3x, and then plus 4. So now I can see the coefficient on my x is -1/3. And it's very important that you don't take the equation in this general form and just say, oh, the coefficient of x is the slope, because it's not. You have to put it into the slope-intercept form. That's why it's entitled slope-intercept form, because you can clearly see what the slope is and what the y-intercept is. So very important that you put it in this form first before you announce what the slope is. Now, the question here did not ask us to find the equation, but it said to find the slope. So let's answer what the question is asking us. So if line 1 has a slope of -1/3, then line 2, the slope of that would have to, and it says any line, not just one line, anything that's perpendicular would have a slope that is the reverse, the inverse or reciprocal of this. So 3/1, and then the opposite sign, so positive. So I would just say that the slope here of any perpendicular line would be 3. Slope as the rate of change. Slope is defined as the ratio of the change in y to the corresponding change in x. It describes how fast y is changing with respect to x. For a linear function, the slope may be interpreted as the rate of change of the dependent variable per unit change in the independent. Let's explore the slope a little bit, and we'll explore it by taking a look at our calculator. And you can follow along with me on your calculator. So here's my calculator, and I had this equation in there originally. So let's just go from this. We have a slope here of 3. I want to take a look at what happens when I have a slope that is smaller than 3. So let's do a slope of 2. And actually, let me change this. My y-intercept is so high that I can't see it, so I'm going to change it to something that's a little bit lower so that I can see it better. So now I can see it better. So the first line that had the slope of 3 was in blue, and the second line that had a slope of 2 was in red. So we can agree that the blue line is a more steep line. And so if I had a number larger than 3, let's try 5. That line would be steeper yet. And if I have a number that is a lot smaller, let's say 0.5, that one would be the least steep of all of them, almost horizontal, right? So let's draw a conclusion from that. So we'll say if you have a positive slope, the closer the slope is to 0, the less steep the line is. The larger the slope, the steeper the line is. And now let's explore it with negative slopes. So let me clear out what's here. I'm going to just highlight each one and hit the clear button. And then I'm going to insert a negative sign. So here's negative 3. Let's do negative 2. Oops, put it in the wrong location. Let's do negative 2x plus 4. So all I'm changing is the slope in each one. I don't want to change the y-intercept because I'm trying to just compare what happens when I change the slope. So we can see that when I put in negative 2, that was the red line, that was less steep. But I put in negative 5, that's further away from 0, more steep of a line, more of a fall. When it's negative, the line goes downward. And if I put in negative 0.5, which is the closest number, the closest slope to 0 here, that's where I'm going to see the line be the less, that's the least steep here. So I'm going to write this as my conclusion. And negative slope, when you have a negative slope, the closer the slope is to 0, the less steep the line is. The closer, or the further, I should say, the further away, so closer to negative infinity, the steeper the line is. So those are just some observations of a positive negative slope. And now we want to take a look at, sometimes we don't always have linear functions, but talking about slope as a rate of change, and we're going to look at that in the next video.